Hi y'all, today I'm going to be teaching some more concepts of meteorology with my homework 1, part 3B. The lifting of air. So there are four different types of the lifting of air. Today we're going to talk about the orographic lift, the convective lift, and convergent lift. In the orographic lift, in this first picture here, you see that it is forced to rise over the mountain, causing a wet side of the mountain on the left, and then a cool air is descending down the side of the mountain, which would leave the drier section where there's not going to be as much precipitation as the left side of the mountain as there is on the right side. So the moist air going up the west side of the mountain, we'll say, is going to have a more chance of precipitation, and that's the orographic lift, where it is forced up. I mean, it can't go through the mountain, so it has to go up the mountain. In the convective lift, it is the unequal heating of Earth's surface. So you have the warm ground here, and it causes air pockets that are bunched together to rise because of their buoyancy or their density. So we see that the moist air is going to rise and cool. The warm air is less dense, so it rises. That's the air near the ground. So it's going to be warmer near the ground because of the heating of the Earth's surface. And as you see, then it rises to cool, and then depending on where this can create clouds and therefore can have precipitation in the convective lift. In the convergent lift, is over here on the far right, is where air that has difference in air masses is forced to rise. So you see air coming in from the left and to the right, and as it mixes or it piles up, the air is then piled up, creating the upward lift as it comes up right about here. It's kind of like when there is a crowd. So if you're walking in New York City, and everybody is coming into this huge space here, but trying to get down this little area, you're just going to all kind of like push your way through to get to the destination. That's kind of how you think of a convergent lift, because you can't all keep going straight because the entrance of a building is narrow and such like that. Next up, we have the different types of precipitation. So precipitation is formed in clouds. So all precipitation, or most precipitation, starts as snow crystals or other solid forms of water, but then as it proceeds to go down, it changes when it hits the ground, and we'll talk about that. So rain is when the ice crystals that enter warmer air. So here we have rain. So it's gonna all fall and it's gonna melt. It's gonna essentially be the ice crystals that have melted, and they fall as raindrops. Snow we have to the left. Those ice crystals that are started stay at that formation as they fall to the ground. Some fall a little bit warmer, and that's when you have kind of like wet snow, versus colder, light, fluffy snow. We don't get as much of it in Oklahoma, but in New York, you get a lot of wet snow that kind of melts as it comes down, but doesn't completely turn into rain. Then we have sleet. That is when raindrops fall to the ground and then freeze, creating a sheet of ice on the ground. So this is going to kind of fall. It's almost like a mixture of snow and rain. It's falling. It's kind of like rain, and then it gets to about here, hits the ground, and then it freezes. And a lot of times you'll see black ice when that happens. And then we have hail. It is produced only in cumulonimbus clouds, where there is an abundance of supercooled water. And therefore, as this precipitation falls, it collects the supercooled water as they fall through the clouds, and it kind of like bundles up, kind of like the snowball effect. As it goes down a mountain, it's going to keep collecting these supercooled cells, and then it's going to just keep getting bigger and bigger. So with hail, it might fall down and then come back up, collect some more supercooled ice crystals, come down, and go up, and the pathway might be going up and down through the clouds. Therefore, it's going to keep collecting layers of ice. There are 4 types of fronts that we will be talking about. These are the pictures that go along with it that you would see on a weather map. The warm front is red, the cold front is blue with the triangles, stationary front is back and forth, and the occluded front is purple. So in the warm front, as you see here, the warmer air masses is going to push into the cooler air, bringing stormy weather. So essentially the warm air moves to the colder air, and here's the front, and there would be, thunderstorms or rain clouds and all of the different weathers that come along with warm fronts. Here we have a cold front where the cool air moves into the warmer air. So same thing, this is where clouds are formed. And it will create showers and thunderstorms if there is moisture. So it could just create the clouds that aren't fluffy and are full of precipitation, but it could still create clouds. In an occluded front is where a cold front, you see here, is meeting a warm front. It has the warm air and cool air are separated. The cool air takes over the warm air. So here, the cool air is just kind of like saying this is where I'm going to be. All sorts of weather is possible with an occluded front. It's not to say that it's going to be stormy or fair weather. Anything can happen. I guess it's going to depend on the pressure systems on top of the cool or warm air. And then we have over here the stationary front, which is a transition area between 2 air masses. So it's kind of like the warm air looks like is going up, the cool air is going down, and that's where it's going to form where cold or warm front slows down. So it's not exactly going to create the bad weather or the fair weather. It's kind of in the middle. It usually stays in the area for days. This is what you're going to see when we have like a stretch of rainy days or a stretch of fair weather days. And it creates cloudy skies and continuous precipitation. So I guess it's going to create more of those rainy days than it would fair weather days. But like those overcast days that just are kind of gloomy, that's where you would get a stationary front. Have a great weekend.